Let's now consider this confidence interval problem. The postmaster of Atlanta finds that 44 packages out of a sample of 650 had insufficient postage. Find a 95% confidence interval for the probability that a randomly selected package has insufficient postage. This is a confidence interval problem involving a proportion. Now, as discussed in class and in the book, for this problem you do not want to use the built-in confidence interval function on a TI calculator or in some versions of computer software packages in order to match the answers that appear in the book. This is a fairly modern interpretation of the confidence interval that is more accurate than the one that has been historically used and is traditionally programmed into software packages and in the TI calculator. The formula for the confidence interval is up here in the upper right hand corner, and this is derived, we derived this in class by solving a certain quadratic formula for the endpoints p to make the confidence interval work. So it's a fairly complicated formula. We will just simply practice how we use it here. So in this case, p hat is the proportion of successes, so 44 successes out of 650, so 6.769%. Q hat in the formula is 1 minus that, the proportion of failures, so that is equal to 1 minus B1, which is 0.9323. Then we have P tilde, which we need here. That's going to be the center of the confidence interval that we construct. Is going to be a little bit different than the P hat value. So the way we get this, we first need to get the Z value. So that's going to be norm S in this case of 0.975. So that 2.5% of the area lies to the right and 2.5% of the area lies to the left, with 95% in the middle. So let me draw the picture before hitting enter there. So we have a confidence interval problem. We have 95% of the area is supposed to lie in the middle. So 2.5% lies to the right, and 2.5% of the area lies to the left. So I need norm S inv of 0.975 or inv norm 0.975 on a calculator to be able to determine the correct value. So the Z value that I need is 1.96. So P tilde will be equal to, well, P hat, which is B1, plus the Z value squared, divided by 2 times n, which is 650, over 1 plus the Z value squared, divided by n, which is 650. So my P tilde is going to be a little bit different than the P hat value. As n goes closer to infinity, both of these extra terms are going to 0, so I eventually get P hat. But for n that is not infinity, I get a number that is somewhat different. Finally, the margin of error will be equal to the Z value, B4, times the square root of, well, I need P hat times Q hat, so B1 times B2 over n, 650, plus Z squared, which is B4 squared, divided by 4 times 650 squared, all divided by the same denominator that we had in the formula for P tilde, which is 1 plus Z squared is B4 squared divided by 650. So that is the formula for the margin of error, which is 0.194. So ultimately, we finally get the answer that, let's put it over here. The margin, so the confidence interval will be 0.7023 plus or minus 0.01942. So I'll write that down. So 0.07023 plus or minus 0.01942. And in this case, that will be the 95% confidence interval for the proportion of all packages that have insufficient postage.